Well, welcome. Today in pre-calculus, we're going to be solving trigonometric equations. Our objectives are to use standard algebraic techniques to solve trigonometric equations, to solve trigonometric equations of the quadratic type, to solve trigonometric equations involving multiple angles, and to use inverse trigonometric functions to solve trigonometric equations. So before we start solving, we'll just talk about solving for a second here. In order to solve a trigonometric equation, we use standard algebraic techniques when possible, such as collecting like terms and factoring. Your preliminary goal in solving a trig equation is to isolate the trigonometric function on one side of the equation. A solution that you solve for correctly but does not check is called an extraneous solution. So let's go ahead and get started with our problems for today. So the first thing we're going to start out is checking to see what is a solution to an equation. So in example 1, is the given x value a solution of the equation? The cosine of x is equal to the square root of 2 over 2. If I'm given that x is equal to pi over 4, let me go ahead and scoot this over so that it's a little better there. Okay. So if I want to know if pi over 4 is a solution to this equation, I'm going to substitute the pi over 4 in my equation. And I'm going to say, okay, is the cosine of pi over 4 equal to the square root of 2 over 2? Well, yes, it is. So the cosine of pi over 4 is equal to the square root of 2 over 2. So x equals pi over 4 is a solution for this equation. Why don't you see if you can find out for the sine of x is equal to 3 pi over 2, is x equal to pi over 6 a solution? You can pause the video if you'd like to. If I plug in pi over 6, I'll ask myself, is the sine of pi over 6 equal to the square root of 3 over 2? And it's not, because the sine of pi over 6 is 1/2. So the sine of pi over 6 is not a solution for this equation. Why don't you pause and try this one? So my equation is the cosine of x is equal to negative 1/2, and I want to know, is the x value 2 pi over 3 a solution for this equation? So is the cosine of 2 pi over 3 equal to negative 1/2? Yes, it is. Therefore, I know that 2 pi over 3 is a solution for that equation. Let's try one with tangent. Is the tangent of 2x equal to negative square root of 3 over 3? And I have an x of 5 pi over 12. So I'll plug the 5 pi over 12 into my equation, but I'm going to need to multiply the 2 times the 5 pi over 12. So that's going to give me the tangent of 5 pi over 6. So is the tangent of 5 pi over 6 equal to negative square root of 3 over 3? Yes, it is. So x is equal to 5 pi over 12 is a solution for my equation. Now I'm going to have to plug in pi over 3 for both places here. So is the cosine of x equal to the sine of 2x? So I'll plug pi over 3 everywhere there is an x. So is the cosine of pi over 3 equal to the sine of 2 times pi over 3? Is the cosine of pi over 3 equal to the sine of 2 pi over 3? Well, the cosine of pi over 3 is 1/2, and the sine of 2 pi over 3 is the square root of 3 over 2. So no, that's why I x'd it out. No, that is not a solution. Now feel free to pause or stop the video at any time that you would like to practice or take notes. So now we're going to start solving equations. And what I want to do is I want to find all of the solutions on the interval from 0 to 2 pi. And see, the bracket here means that 0 is included. So all of the values including 0 up to 2 pi, and the parenthesis here means that the 2 pi is not included. So basically all the solutions on the unit circle that satisfy this equation, the sine of x is equal to the square root of 3 over 2. So I'm going to think to myself, x is equal to the inverse sine of the square root of 3 over 2, which really means I'm looking for the theta, or the angle, whatever you want to call the angle, that is going to give me a ratio of the square root of 3 over 2. It's a positive angle, so on the interval from 0 to 2 pi, sine is positive in quadrants 1 and 2. So those are the only quadrants I have to look in. And the sine of pi over 3 is equal to the square root of 3 over 2, and the sine of 2 pi over 3 is equal to the square root of 3 over 2. Therefore, my solution is x is equal to pi over 3, and x is equal to 2 pi over 3. If I only thought about the inverse sign, I would have only gotten this answer here, but I have to make sure I find all the solutions on the interval from 0 to 2 pi. How about the tangent equal to 1? Now remember, I'm still going from 0 to 2 pi, so where on the whole unit circle is the tangent of x equal to 1? So I'm going to think about x as the inverse tangent, or the arc tangent of 1. And tangent is positive in quadrants 1 and 3, so I'll look in quadrants 1 and 3. And the tangent of pi over 4 is 1, and the tangent of 5 pi over 4 is 1. Therefore, my solution is x is equal, my solutions are actually, x is equal to pi over 4, and x is equal to 5 pi over 4. Why don't you pause and try this one? I'm still looking for all the solutions from 0 to 2 pi. I know that the cosine is negative in quadrants 2 and 3, so I look for the angles in 2 and 3 that would have a cosine of negative 1/2. And I know the cosine of 2 pi over 3 is negative 1/2, and I know the cosine of 4 pi over 3 is negative 1/2. Therefore, my solutions are x is equal to 2 pi over 3 and x is equal to 4 pi over 3. This one's a little more complicated because what I really want to do, if I have 2 times the cosine of x plus the square root of 3 is equal to 0, I want to isolate this trigonometric function here. So I want to get cosine of x by itself. So I'm going to subtract the square root of 3 from both sides of the equation and divide by 2. I'm still talking about the interval from 0 to 2 pi. So I'll go back to my unit circle values, and I know that cosine is negative in quadrants 2 and 3. And I have the cosine of 5 pi over 6 is negative square root of 3 over 2. The sine of 7 pi over 6 is equal to the square root of 3 over 2. Therefore, my solutions are the cosine of, oh, I'm sorry, this should just be x. So my solutions are x is equal to 5 pi over 6 and x is equal to 7 pi over 6. Why don't you pause and see if you can solve for the sine of theta first and then find the solutions. I'm going to get all my sines together, so I'm going to subtract 2 sine theta from both sides of the equation, which is going to give me 2 sine theta minus 1 is 0. I'm going to add 1 to both sides of the equation, then divide by 2. Sine is positive in quadrants 1 and 2. The sine of pi over 6 is 1/2. The sine of 5 pi over 6 is 1/2. Remember, we're only restricting our solutions to from 0 to 2 pi. There are times, in later times that we will, or in the next course, where you'll find all the solutions from negative infinity to infinity. But right now, we're just finding all the solutions from 0 to 2 pi. So I know that x is equal to pi over 6 and x is equal to 5 pi over 6, and those are my solutions. Why don't you try this one? I'm going to get my sines together by adding 2 sine theta to both sides of the equation. I'm going to subtract 5. I'm going to divide by 5. Now I have the sine of theta is negative 1. I'm talking about negative values, so I'm in the quadrants 3 and 4. And my only solution is 3 pi over 2. Now this one's a little different. I have a square here, so I'm going to isolate my sine squared by adding 1. And then I'm going to take the square root of both sides, which gives me a plus or minus 1. So I end up with the sine of x as a positive 1 and a negative 1. And the sine of x on the interval from 0 to 2 pi is equal to positive 1 at pi over 2, and is equal to negative 1 at 3 pi over 2. So those are my 2 solutions. Now this one's a little tricky because I have 2 times the sine squared of x minus the sine of x minus 1 is equal to 0. And it really needs to be factored. So in order to factor it, and this is a pretty good technique even if you're doing SAT problems or other types of critical thinking problems, I will take and model this with a simpler factoring problem. So I'll think of it like 2x squared minus x minus 1 is 0, and I will factor that problem. And I'll get 2x plus 1 times x minus 1 is equal to 0. You do slip, divide, slide here, or you can factor by trial and error. And I'll use this to model over here. So I will take my 2x plus 1 and I will turn that into 2 sine x plus 1. I'll take my x minus 1, I'll turn that into sine x minus 1, and now I'll go back to working my trig problem. So I will set each one of those factors equal to 0. Then I will solve both sides, and I will find all of the solutions where the sine of x is negative 1/2. I get 7 pi over 6, 11 pi over 6, and where sine of x is 1, and that is pi over 2, because like I said, we've restricted our domain to 0, from 0 to 2 pi. So I have 2 times the cosine squared of x plus 3 cosine x plus 1 is equal to 0. You can factor straight from the trig functions. Lots of people can do that, but it's a lot easier, especially in the beginning, if you think of it by modeling an algebraic expression or an algebraic equation to factor it. So you may want to try this. So if I factor 2x squared plus 3x plus 1 is equal to 0, I get 2x plus 1 times x plus 1 is 0. And I will use those to go back over here to the trig function and change this to 2 cosine x plus 1 times the cosine of x plus 1 is 0. Set each factor equal to 0. Solve for the cosine of x in each one, and then find all the angles on the unit circle from 0 to 2 pi that satisfy those conditions. So the cosine of x is negative 1/2 at 2 pi over 3 and 4 pi over 3, and the cosine of x is negative 1 at pi. And those are my solutions. So the first problem we're going to solve is we're going to solve the 2 times the sine of x is equal to negative 1. And when I'm solving trigonometric equations, sometimes I will solve it on a specified domain. If a domain is not specified, then I have to solve it for a domain of all real numbers. So we're going to talk about both types of situations today. So if I wanted to solve 2 times the sine of x is equal to negative 1, my first step is to isolate the trig function. So I'm going to want to get the sine of x by itself by dividing both sides of the equation by 2. And I end up with the sine of x is equal to negative 1/2. So I think to myself, where on the unit circle is the sine of x equal to negative 1/2? So instead of just taking the inverse sine and restricting it to the domain that's restricted for the inverse trig function, I'm going to have to think about all the values on the unit circle where the sine of x is negative 1/2. So from 0 to 2 pi, I know that x is equal to 7 pi over 6 and 11 pi over 6. And so that would be the solution if I was only talking about unit circle values between 0 and 2 pi. But since this domain is not specified, I'm going to need to go ahead and append the period. Appending the period, I need to know that the sine of x, the period, is actually 2 pi. So every time I add 2 pi to 7 pi over 6, or every time I add 2 pi to 11 pi over 6, I'm going to get the same sine value of negative 1/2. And so this is more of a global solution instead of just a restricted domain solution. So I'm going to have to globally add the period of pi. Okay, so I'm going to take 7 pi over 6 plus or minus, because I can add or subtract it, 2 pi, and each time it's going to bring me back around to that value. But I will do this an infinite number of times. So it's 2 pi times n, which means 2 pi times 1, 2 pi times 2, 2 pi times 3. And then I will also do the same thing with 11 pi over 6. And so my global answers, if the domain is not specified, is x is equal to 7 pi over 6 plus or minus 2 pi n, or 2 n pi, however you want to write it, and x is equal to 11 pi over 6 plus or minus 2 pi n. So let's go ahead and solve 4 times the cosine squared of 2x is equal to 3. Well, the first step is to isolate the trigonometric function. So I'm going to go ahead and divide both sides of the equation by 4. And I have a 2x in here. Now this is called a multiple angle, so that kind of causes me to have to do a little bit more work because it's not just x. So the first thing I'm going to do is I'm going to take this is squared, so I'm going to take the square root. I'm going to start undoing it like it's an onion, I guess, or something like that. So I'm going to take the square root of both sides, and so the cosine of 2x is equal to plus or minus the square root of 3 over 2, because I went ahead and simplified the denominator. And then I will take the inverse cosine. So when I ask myself where on the unit circle, because that's where I'm always going to start, is the cosine equal to plus or minus the square root of 3 over 2, then I'm going to say, well, 2x is equal to, and I get 4 different solutions. It's equal to pi over 6, 11 pi over 6, 5 pi over 6, 7 pi over 6, because now I'm doing all the positive and negative values. And then I will append the period, and I will always do appending in the period for a multiple times an angle, even if it's just unit circle values, because now I have to take and divide everything by 2. So I want to make sure that I check for everything on the unit circle, even if I had a restricted domain. So now I will divide everything by 2. So when I divide everything by 2, pi over 6 divided by 2 is pi over 12, and then 2 pi n divided by 2 is pi n. And so I have 4 distinct answers here. But if I think about it, there's an equidistance of, notice I have the asterisk here, the 2 red asterisks and the 2 green asterisks, because really there's pi over 2 difference between pi over 12 and 7 pi over 12, and then if I add it back, I'll come over here. So a more concise way to write the answer would be to say that x is equal to pi over 12 plus or minus pi over 2n, which would take me to 7 pi over 12, and then back again. And then to say that x is equal to 5 pi over 12 plus or minus pi over 2n. So this is an acceptable answer, but this is the best answer. So now I want to solve on a specified interval, and this time I'm dealing with tangent. So 3 times the tangent of x is equal to negative 3. Well, I know that if tangent is negative, I'm going to be getting answers that should be in quadrants 3 and 4, because that's where tangent is negative. So I will isolate the tangent of x by dividing both sides by 3. And I have the tangent of x is equal to negative 1. And so I'm going to ask myself, where in quadrants 1 and 2 is the tangent equal to negative 1? And it's only equal to negative 1 where x is 3 pi over 4 and 7 pi over 4. And since I have a specified domain, those are all the values between 0 and 2 pi, where the tangent of x is equal to negative 1, and therefore 3 times the tangent of x is equal to negative 3. So I don't have to add the period here, which of course the period of tangent is pi, not 2 pi. I don't have to do any extra work there, and there's no multiple angles. So now I have sine squared of x minus sine of x is equal to 0. And I don't have I'm still solving, and I don't have a specified domain here, so I'm going to have to go global with it, with the period. I don't have to do that if there's a specified domain. But I notice that I can factor, because I'm not going to say sine squared of x is equal to sine of x and divide, because you don't divide by a variable. But I'm going to factor out. So I make sure it's set equal to 0, and I factor out the greatest common factor of the sine of x. And then I'm going to set each factor equal to 0. Because I'm thinking x squared minus x is 0, x times x minus 1 is 0, and if I were doing it algebraically, then I would say x is equal to 0 and x minus 1 is equal to 0. So I say the sine of x is 0, sine of x minus 1 is equal to 0, and then I'll continue solving. So I will say, okay, the sine of x is equal to 0 when x is 0 and x is pi, and I'll add the period. You can say plus or minus here, plus or minus here. You know, if not, you're thinking that n is equal to positive and negative integers. When you do plus or minus, then you restrict n to just positive integers. And then I'll say the sine of x is equal to 0. So the sine of x is equal to 1. So x is equal to pi over 2 plus or minus 2 and pi. And here I have, because they are equidistant, there's pi difference between 0 and pi, and back again and back again. So I can say for here, the more concise answer is x is equal to plus or minus n pi. And so my final solutions are x is equal to plus or minus n pi, and x is equal to pi over 2 plus or minus 2 n pi. Now this one's different for number 5, because now I have tangent squared plus secant x minus 1 is equal to 0. But you know, I can't factor anything if I don't have the same trig function, so I have to think to myself, is there an identity that I can convert either tangent into secant or secant into tangent? When I see the square, I'm thinking, well, is there a Pythagorean identity that maybe I can do a conversion? And there is, because tangent squared is equal to secant squared x minus 1. So I'll go ahead and plug that in. And then I will go ahead and say, okay, well, secant squared plus secant squared is, secant squared, bring that down, negative 1 minus 1 is negative 2, and bring down my secant x. So I'll model that algebraically by saying, okay, x squared plus x minus 2, and I can factor it this way. So I'll go back and factor the trig function the same way. Okay, some people can factor straight from here, and that's great. Then I will set each factor equal to 0, because of course I made sure it was equal to 0 before I did the factoring. And then I will solve, so secant x is equal to negative 2, secant x is equal to 1. And there is no, I have to do this globally because there's no specified domain, but I'll say to myself, where on the unit circle is the secant of x equal to negative 2 and the secant of x is equal to 1? And it's easier to change that into cosine. So I will say that the cosine of x is negative 1/2 and the cosine of x is equal to 1. And where on the unit circle is the cosine of x negative 1/2? Well, it's negative 1/2 at 2 pi over 3 and at 4 pi over 3, because of course it would be in quadrants 2 and 3. And then I will say plus or minus 2n pi or 2 pi n, any way you want to do that. And then with cosine of x is equal to 1, that's just at 0. So it's 0 plus or minus 2n pi or 2 pi n, and I don't need to write the 0.